Okay, so you've learned a lot of ways to take derivatives, and believe it or not, this is actually our last video on new derivatives that we're going to learn how to take. And then you really, by putting all the pieces together, know how to take derivatives of all the functions you've learned about. So we're going to look at the inverse trig functions. Okay, so I'm going to show you where one of these comes from, and then I'll give you the rest of them. And these are on your formula sheet, so they're not something I believe you need to memorize. So we're going to look at how we find the derivative of tangent inverse of x. You may also know this as arctan of x, and the derivative is 1 over 1 plus x squared. So if we have this function y equals tangent inverse of x, then that's actually the same, or means the same thing as that x equals tangent of y. That's what an inverse function means, that you can switch the x and the y. So we're going to use implicit differentiation to take the derivative of both sides. So the derivative of x is 1, and the derivative of tangent is secant squared. So here we'd have secant squared of y. Since we're taking a derivative of y, it would be dy dx. So to get dy dx by itself, we would have 1 over secant squared of y equals dy dx. Now we want this in terms of x. So the first thing to notice, well, we also have to use a little trig identity. And this is one of the Pythagorean identities you would have seen in pre-calc, and that's that secant squared of y equals 1 plus tangent squared of y, or tangent of y squared. So substituting that in here, we have dy dx equals 1 over 1 plus tangent squared of y. Now remember what we said earlier right here, that tangent of y equals x. That means right here when we have tangent squared of y, that's equal to x squared. So that's how we get that the derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. Okay, now just to list the rest of them, and then I'll show you kind of how we use them. So the derivative of sine inverse is 1 over the square root of 1 minus x squared. The derivative of cosine inverse is negative 1 over the square root of 1 minus x squared. The derivative of tangent inverse, as we just saw, is 1 over 1 plus x squared. For cosecant, it's 1 over the absolute value of x times the square root of x squared minus 1. Secant is, sorry, for cosecant I should have had a negative out in front. For secant, it's that without a negative. And I accidentally forgot one here. We need cotangent inverse of x. And the derivative there is negative 1 over 1 plus x squared. Okay, so again, these are on your formula sheet. They're not ones that you need to memorize, but we'll use them like we've used other formulas. So here, if we want to take the derivative of cosine inverse of x squared, well, we're going to have to use the chain rule. So we're going to take the derivative of cosine inverse, which is up here, and we're going to plug in x squared, which means we'll get negative 1 over the square root of 1 minus x squared squared. Now we need to multiply by the derivative of x squared, which is 2x. So we can simplify it just a little bit. Okay, so if we want the derivative of sine inverse of 1 minus x, well, the first thing we're going to do is plug 1 minus x into the derivative for sine inverse. So that would give us 1 over the square root of 1 minus x squared. Now we need to multiply by the derivative of 1 minus x, which is just negative 1, so we can just multiply by a negative. And then our last one here, we have secant inverse of 5x, so we're going to plug 5x into the derivative for secant inverse. So we'd have 1 over the absolute value of 5x Now we need to multiply by the derivative of 5x, which is just 5. So we'd have 5 over, we can actually pull the 5 out of the absolute value. All right, this is 25x squared minus 1. And now you'll see that we have 5's in the numerator and the denominator, so we can cancel those out and just put a 1 there.